Hey guys, I want to talk to you about the concept of molar volume. The molar volume is the exact volume that 1 mole of an ideal gas takes up at a certain temperature and pressure. It's going to vary depending on the temperature and pressure, and the most common way that teachers ask for you to do this is at STP, standard temperature and pressure, which is 0 degrees Celsius and 100 kilopascals. So the real question is, if I have 1 mole of gas, what's the corresponding volume that it takes up? Well, volume, according to the ideal gas equation, is nRT over P. Now, let's fill in some numbers and see if we can get the number for molar volume at STP. Well, let's use purple. How many moles do we have? What's N? Well, it's 1 mole, because that's the definition. What's R? I'm going to put my pressure in kilopascals. So I'm going to use the R of 8.314 liters kilopascals per mole Kelvin. You would have to convert this to atmospheres if you're going to use one of the other R's, but just do it my way. Temperature is 0 degrees Celsius. You have to convert it to Kelvin, because that's how you use the ideal gas equation. I add 273, by the way, to get there. And the original pressure was 100 kilopascals. Now let me just make sure my units canceled here. Moles with moles, Kelvin with Kelvin, kilopascals with kilopascals. I'm going to be left with liters. This is perfect. So 1 mole of gas at STP takes up 1 times 8.314 times 273 divided by 100, 22.7. 22.7 liters. Now, what that means is that we say the molar volume at STP is 22.7 liters per mole. Now this is important because what it means is if we have a volume of 45.4, it's because I have 2 moles. If I have triple this volume, it's because I have 3 moles, etc., etc. So this number, as long as you know you're at STP, lets you convert between liters and moles directly. Oh yeah. Hey, that's what they're asking here. If I have 3 liters of a gas at STP, how many moles are inside? Well, I have 3 liters of gas, and 1 mole of gas takes up 22.7 liters. I'm doing this in a unit analysis style of way. You could also just divide by 22.7, the same way you divide by molar mass. In any case, 3 times 1 divided by 22.7. It means that 3 liters corresponds to 0.132 moles. Not going to worry about significant figures. So, take a look. We can convert directly from liters, easily measurable in a lab, to moles as long as we know the molar volume. And it doesn't matter what the identity of the gas is. We're assuming it's an ideal gas, and the ideal gas law treats all gases the exact same way. Deal? Deal. Now the last thing I want to point out is this thing called SATP, standard ambient temperature and pressure. It's 25 degrees Celsius and 101.3 kilopascals. I'm curious to know what the molar volume is there. The molar volume is number of moles times R, and again I have it in kilopascals, so I'm going to use 8.314 liters kilopascals per mole Kelvin. My temperature is this plus 273, because again I got to convert it into Kelvin, and I divide by my pressure. This is the same formula as the other side of the sheet, so don't freak out that I'm not showing you a formula. 1 times 8.314 times 298 divided by 101.3. 24.5 liters. So the molar volume of a gas at SATP is 24.5 liters per mole. Now, if you see a number that's slightly different from this, I don't know, 24.6, 24.4, I forget what the exact number is. It's a rounding thing, probably, all right? In any case, that's molar volume. It's the exact volume that 1 mole of a gas takes up at a particular temperature and pressure. STP and SATP are the most common conditions to be asked about. Piece of cake, son. Best of luck.